All right. One of my favorite jokes on the internet, by the way, is that somebody sniped the Super Bowl, the sub R/R Super Bowl years ago on Reddit, and instead it is now Superb Owl and has been for the past couple of decades or past couple of years. And so it is all about owls, of course, which I find just wonderful. I have no idea. Um, I think it's ESPN. Uh, or it's just maybe I think it's just slash football for it because CFB is college football. So I think we just so football maybe, except that might be soccer. I wouldn't know. Anyway, so let's go ahead and talk about what we've got upcoming. So I'm not going to spend too much time prattling on today. Again, if you're not feeling well, just feel free to err on the side of caution and stay home. That is perfectly fine. I'll understand it. I've already had some emails from students who said that they got COVID or their roommate has COVID. Not like yesterday, but like days before yesterday, So it's understandable. So if you again, there is no penalty for staying home and being safe. Really? Did I not change this from fall 2022? Okay, whatever. Does not matter. Let's go to assignments. Okay. So we should be so first and foremost, you should have gotten an announcement about a reminder, even though it wasn't really a reminder, but you should have gotten an announcement about a research project participation and taking a survey. It would be awesome if you filled that out. I would really appreciate that. It is about the use of active learning in classes. It's part of so filling that out would be extremely useful. All right. Next is we go to modules. Let's talk about our homework. So array list exercises are due tomorrow evening. If you need more time on that, please let me know. If you're struggling on any particular problem with that, also let me know. Be sure to test the input and output, the inputs that I give you for problem 2.6, because that one will let you know if that program works or not. Now, Big O exercises, I'll set that due date to be next week. I'll always try to make the due date like Tuesday at midnight or so, just as the starting due date, because that makes sense, meaning. So this one is, of course, math homework, because that's weird. Okay. Now this is so Big O notation is something that you'll be covering in both that you probably will have seen in 1166, 2166. So Math Concepts 1 and Math Concepts 2. Did you get exposure to it in Math Concepts 1? I'm always fuzzy about that. Okay, Math Concepts 1, no. What about Math Concepts 2, 2166? So I care about so they can deal with the formal definitions of Big O and what it means for one function to dominate another function. Honestly, that we can leave more of the more formal stuff like the master's theorem back to 3223, which is the next course for computer science majors and some data science majors, which is the algorithms class. For here, though, for data structures, I care about more informal stuff. What does Big O notation feel like? What does it mean what happens when we have an O of n algorithm versus O of n squared? We will be working with 5 kind of growth notations throughout the semester. Constant time notation, basically saying, hey, return something to me. So this is something that's constant time. As an example, that is looking up the size of something. That generally takes constant time because that's stored in a variable. O of n time, which is when we need to search for something. O of n squared, which is the time that usually takes if you have to compare something to everything else, or if you have to compare every single pairing you've got. So those are the 3 big times we'll start out with. Then we'll eventually, as we get to recursion, we'll learn about logarithmic time, which isn't as scary as it seems, because logarithms you were taught very poorly, or at least if you were taught the same way I was taught them, you were taught fairly poorly. Math education has actually gone better, so You may have actually learned the proper way to think of algorithms in terms of splitting things into piles. But logarithms are very easy to kind of understand what they do in computer science. And then you'll also learn n log n, which is a bit more kind of, wait, what is that? But it makes sense over there. So unlike most of your math homework that you would do for math classes, you're going to be demoing this in the sense that you're going to come to me, and rather than handing it in like you would on paper or anything. First off, I don't care how you hand this in. You can do this on paper and then upload it, take pictures of it and upload it. You can just edit the PDF or turn it into a document to upload it, or just do a text file with all your answers on it and upload that. I don't care. I don't care how you do it. Do whatever works best for you. But the point being is that you will sit down with me or the TA and we will go through what answers you have, and I'll check them all off. If you don't get them right, I'll point out which ones you got wrong. And depending on the complexity of the problem, I'll point out why you got it wrong and give you the chance to go back and fix it. Because I always found that weird with math homework, that like if you make a mistake and it completely messes stuff up, but you don't get the chance to kind of fix that mistake, because then you can just make that mistake over and over again. It doesn't really teach you not to make that mistake. So over here, we've got basically these times that I want you to translate into big O notation. You follow these two rules that I have up here to figure out what the answers are, okay, for those first two, okay, as well as watching the videos, but primarily these, that only the highest factor matters, sorry, only the highest degree of n matters. So the idea here is that as n approaches infinity, in other words, as n gets really big, like 100 to the 100th power, okay, the n cubed, as it gets bigger and bigger, everything just starts resembling n cubed. The 5n squared plus 10 to the 7th power, that just doesn't matter anymore. It's a blip. It doesn't even register as error in terms of numbers that big. When the numbers get really big, only the highest degree matters. And that's what we say. The highest degree here is O n cubed, so the curve follows O of n cubed. Okay? The other thing is that the constant factors don't matter, which is that if you've got numbers attached to your degrees, you just toss them out. Don't care about them. And that helps you figure that out. So here we've got, again, 50n cubed, and that just becomes n cubed. So we do that for these. The only pitfalls I have are, I would say, are problems 3 and 4, which if you've taken Calc 2 and remember it, which is also the important part, and remember your infinite series, then you might remember these. Then you might remember these from doing Taylor series. Not Taylor series, just doing convergences. My bad, convergences. And if you haven't done those, I recommend Googling these series by going 1 plus 2 plus 3 ... all the way up to n. This one has a name for what series it is. This one does not, but it follows the same way. On Thursday, in case you don't, I encourage you to look these up, but if you don't get it by Wednesday, I will go over these two, and I will go over specifically through number 3 in class to kind of show you how this looks both in an informal proof and a mathematical proof by induction on how to see how this converges. So here, questions 11 through 16 ask you about array lists. This is from a puzzle book I had as a kid. I had as a kid, and I rebought it a number of years ago. One of my favorites because it's a bunch of like graph puzzles and maze puzzles on it, so it's very fun. But anyway, this one is a puzzle from the book, and then you can go through and solve it if you want. But I ask you about 2 questions about it, which require you to do some Googling. That's fine. What is because I'm asking you, hey, what is a Rudrada path or a Hamiltonian path? So obviously you don't know what that is. I don't go over to my lectures. You're obviously going to have to look that up. Okay, that's fine. And then I say, okay, let's take this puzzle, which has 35 stars in it, and we're going to instead make it n stars. Okay, now what is the amount of time? And then I'll figure out how long this puzzle takes to solve or estimate. All right, and then we're going to talk about the second to last page goes over BOGO sort, which is one of 2 algorithms that exist solely for the purpose of analysis in class. BOGO sort is the idea of I want to sort something by well, it's essentially the 52 card pickup version of sorting. If I want to sort a deck of cards, I throw the deck of cards up into the air, gather all the cards up, check to see if it's sorted. If not, repeat. So how long does that take? Is the kind of the question. This only exists, again, obviously, like sorting things by just shuffling it at random, not a good strategy. So we just kind of want to quantify how bad it is. Again, feel free to look this kind of thing up in Wikipedia. They ask you about both the worst case and the justification for the worst case, as well as the average case and what is the justification for the average case. The other one that only exists in theory is stooge sort, which you solve, I believe, the first 2/3 of the list, the second 2/3 of the list, and then you resort the first 2/3 of the list again. And that's done recursively. So for the first two, and then finally for question 23, the last ones, for each of the methods you wrote in lab 2, so each of the problems you did for 2.6, I want you to give me the time complexity of the method you wrote. Now, the attaching a printout, that would matter if you're actually handing it in physically. It's sufficient enough for you to like take a screenshot of your code and like paste it in, or attach your code with comments or something. That's fine. Again, do what's easiest for you. But I want you to analyze your own code. Tell me what the time complexity of the code you wrote is, and I'll give you a hint. There's only three times that matter for working with lists at the moment, and that's constant time, linear time, and quadratic time. And none of you would have it's not possible to write constant time for any of the functions we wrote. So your answer for all of your functions are either O of n or O of n squared. Okay. And if that made no sense to you whatsoever, please feel free to watch the videos I did on Big O notation. I don't know why I still have those overview pages, even though they don't have anything. But here again, I talk about Big O time. I'm linear analysis. I go over bubble sort. It's a terrible sorting algorithm, but it's kind of classic. I have a friend at Google who says that we should just stop teaching it because it's that terrible. Even the other terrible sorting algorithms have their use cases. Selection sort has a use case. Insertion sort has a great use case. Bubble sort has no actual use case. So that's that one. Now, once you are done with that one, module 3, module 4 is kind of the hump in our difficulty. It's like the first big hurdle we have. If you can get through module 4, though, it's very sufficient to say that you'll probably be able to get through the class. Okay, so module 4, which is linked lists. The reason I say that is that requires you to think of references and really understand how references work, or if you're coming from C, how pointers work, but also in how, and I will repeat this phrase over and over. In Java, the value on the right gets stored in the variable on the left. That is always how you interpret these very complicated assignment statements that I'll be doing. But once you understand them, you'll understand them. For that one, you will have your choice of 2 assignments, okay? For module 4, you have your choice of 2 assignments. Both of them use the same base code. One is much easier than the other. Joseph's problem, that basically requires you to just work solely in the Java class that is provided to you. Whereas solitaire encryption requires you to work in the Java class that is provided to you, as well as create a new one to do encryption using the data structure you just created. Now, why in the world would you want to do the one that's more of a challenge? Because I'll give you 20 extra points for doing it. That's why. So, and because these things are worth, now this assignment is worth 200 points as opposed to your normal 100, because I give you a bit more extra time to do this one, the module 4, which is again what we'll be talking about next week, not this week. But just start thinking about, okay, do I want to do the more comfortable one versus the less comfortable one for yourself, depending on how you're feeling and what kind of time commitments you have. And again, they're very good problems. They are very good problems, and I really enjoy solving them. But they are kind of like the first hump of difficulty that we have to get through. The second one is recursion, and then the third one is cheater's hangman. Those are the kind of the big assignments that we deal with. Now, the way this works is that you will get you will get credit on the one you do, and then you'll get 0 on the other, but I drop 2 grades, one of which is one of these grades, you know. So technically what happens, I drop 1 grade, but because of the way it's programmed into the grade book, it will say I drop 2 lab grades. So I drop whichever one you don't do, so that I can, and this is so that I can, you know, make sure that credit is given for the one you do. All right. So that is that. Any questions before we get to work on demoing stuff, asking questions about array lists or any of that? So this is currently week 3. I would not expect an exam until week 6. That has been the norm for the past couple semesters. Week 6 is around where we get the exam, and the exams will be given in lab. Okay. More on that will be provided later, but also know that I do provide practice exams at least a week before the actual exam. And the practice exams, I do try to make them harder and longer than the actual exam, because that way you kind of get the feeling, if you know you can do that, if you know you can do this one, then you can definitely do the actual exam. And if you struggle with the practice exam but can get through it, then you probably will struggle a lot less with the actual exam. All right. All right. So my battery is a bit low on power, so if you demo, I will probably retreat back here to go ahead and enter your grade. So anyway, you need help? I'm here. Let me just make sure I'm stopped recording. Recording. Stop recording.